In this biodemographic short, I consider lifespan limits, the challenges in data interpretation. Improvements in survival with age decline after age 100, and the age at death of the world's oldest population has not increased since 1990. These observations led researchers Dong and his colleagues in 2016 to suggest that the maximal lifespan of humans is fixed. These authors argued that the data suggests two trends based on the data they plotted, as shown here with age on the x-axis and maximal reported age at death on the y-axis. Other ways to interpret the same data can be explored as shown in this panel of 6 graphs. Again, it is year on the x-axis from 1960 to 2010 and maximal reported age at death on the y-axis. Here are the data in the upper left graphic. The top middle graph are the same plots contained in the paper by Dong and his colleagues. However, there are a number of different ways to interpret trends than the way they did in these same data, including a straight linear line increasing through all points as in this upper right plot. 3 different regressions, each with different slopes, as shown in the lower leftmost graph. Another could be a much steeper trajectory for the second cluster of points, as shown in the lower middle graphic. And a fourth, among many others, would be separating out the data but seeing an increasing trend in the second subset of clusters, as shown here. Questionable assumptions raised by others about the dataset partitioning include the use of the same dataset both to propose an hypothesis and to test the hypothesis. Lack of support for their broader argument from a biological perspective. Arbitrariness of fitting separate regressions. Small sample size, i.e. 21 individuals for 1968 and 12 individuals for 1995 through 2006. No comparison with alternative models, and the results largely depended upon a single case, that is 122-year-old Jean Calment. Clearly, the question of limits to the lifespan of humans still remains open.